this is our session for end of life starts at the beginning of life is what we call it. And I'm Jenny. I'm with Renewance. I'm joined by Tom Newhall, our co-founder and CCO, and Bruce Fulmer, our director for project management. So the idea is very simple but very powerful in that we should think about batteries at the start of its life, and so that everything that we do within its life cycle drive us to a successful, safe, and responsible management of it at the end. So in this session, Tom and Bruce will shed light based on what they've seen in many, many years in the industry and servicing a good number of our customers on what it means for the life cycle of the battery, how it plays out. And then we'll also talk about much kind of under stated part of the industry, and that is the decommissioning and what is along with that. All right. So we'll do a like a fireside chat of prepared items that we want to highlight, and then we'll open the floor for Q&A, and everybody can ask Bruce and Tom good questions. Okay, so we start off with you, Tom. Why do you say that end of life starts at the beginning of the life of the battery?
Yeah, it's actually a tagline we use quite a lot, that proper end of life planning starts at beginning of life, because actually end of life can happen on day one. Anyone who's installed an energy storage system knows that batteries get damaged during installation. Sometimes there's an occasional manufacturing defect, and then once it's in early stages of operation, there may be some misuse of the system. And so when that occurs, all of the same considerations that apply to the system that operated 15 years apply to those batteries that have failed early. And so you really need to understand, what are your regulatory obligations? Where do you send those batteries? How are you going to package and transport them? If you plan, for the worst from the start, you're going to avoid a lot of scrambling later on. And so what it really means is just kind of upfront planning, knowing your obligations, knowing your role in the value chain, but certainly as a owner operator, you have certain obligations for those batteries, having traceabilities to the batteries you own, understanding that, how you're going to deal with the unexpected, failed or damaged units, those kinds of things, treating that as a day, treating that as a day zero requirement. Make sure that you're going to be able to comply with all of your regulatory obligations down the line. Yeah, so I'll turn it. That's my thought on how how we apply planning to beginning of life.
Thank you, Tom. I'll turn the question to Bruce. How do you see it from a project management standpoint?
Yeah, thanks, Jenny, and welcome all. Project management scope and accountability are really everything. Too often projects push the decommissioning out of scope, but the law doesn't, right? So owners remain liable under federal and state regulations around the hazardous waste, no matter really what the contract says. That means you can outsource the execution of a end-of-life scenario, but you can't outsource the liability as an owner. Owners are accountable until those batteries are safely recycled at a permitted recycling facility. I'd also say that we're seeing more and more utilities and AHJs, the authorities having jurisdictions, starting to require decommissioning plans and even set aside funds prior to the project's approval during the permitting phase. And they recognize that you can't treat the end of life as an afterthought. So if you don't include the end of life planning up front, as part of the overall project, you really don't have a complete plan.
All right.
Yeah.
And as a follow-up, so we talked about that, but what does the good end of life planning look like at each of the stage of the battery life cycle?
Yeah, I mean, Bruce's commentary there is a good segue into what I was going to say, is that really, at beginning of life, it's all about having a solid decommissioning plan. Most jurisdictions are going to make that as a prerequisite for gaining approval for a new energy storage system. And so, a solid decommissioning plan is going to address, local, state, federal regulations. It's going to identify, every component in the system, how those components are going to be disconnected, how are we going to manage that waste stream. And it's also going to include some guidance on how to deal with kind of the unexpected, incidents where the system may have been damaged and leaving it with stranded energy. And so, as Bruce pointed out, another component of a decommissioning plan is really trying to understand the expected costs for decommissioning of the system so that bonds can be obtained to ensure that the financial liabilities are covered. Long ago, back when I started in the industry, that discussion around financial liability was often just a can that was kicked down the road. No one wanted to talk about that during commercial negotiations. That all changed about 5 years ago when NFPA 855 introduced this concept of requiring a decommissioning plan. And then a couple years ago, 2023, I believe it was, the standard was updated to reinforce that decommissioning plans really ought to be submitted during the permitting process.
And during operational life?
Yeah, I might tag on to that, what Tom said, Jenny, during the operational life of a system. I really say a few things. One is record keeping is critical. I'd say, service logs, state of health data of the system, performance records. They don't just help with the uptime of the system. They also determine what potential end-of-life options that you might have. If you have good data, you might extend the life of a system with selective replacements or augmentation, repurpose modules into potentially some second life applications. However, without the data, you're often forced into the most expensive option, which is just you've got nothing else but the full recycling of the system. So operational practices, I'd say, are really the bridge between the design and the retirement of your system. And I might throw in another, in addition to the operational data, there's other things that are important to keep current throughout the life of a project. Because if we think about this, the folks that are involved in the beginning of the project, the permitting, the financing, the building of the project, they may not be, in fact, they likely aren't going to be the folks that are around at the end of a life of a system, if it reaches its natural life in 15 years. So record keeping there is really comes into play. That's the O&M manuals, that's, line drawings, underground conduit, schematics, that sort of thing. So when you have to take a system out, the end of life, if we have all that information, it makes it a lot easier for the planning of how that system can come out most economically. So just keeping good records and data, I think, is a good theme here.
And when we finally get to the end of life?
Yeah, I mean, I think we've touched on a couple topics here, but step one when we've reached, end of life is determining whether or not your battery is considered waste or product. So as an example, batteries that are going to be destined for reuse or repurposing are not considered waste, and they're typically going to be managed just like a new battery. You're going to follow DOT regulations for packaging and shipment and such. if the battery is now considered waste, meaning you have made the decision that you're going to send it for recycling, then it's considered a universal waste if it's intact, and that comes with specific requirements that the EPA implements. Ultimately, the owner operator of the BESS system or an EV is considered the waste generator in the eyes of the EPA. Bruce referred to that a short time ago. And the EPA has a number of, implements a number of obligations on the waste generator, namely, how much waste can you accumulate before you need to notify them? How long can you store it? How do you market label it? Record keeping requirements. So all of those things are dependent on how you classify the battery that's now reached end of life. As I mentioned in my previous statement there, systems that have gone through an unexpected event, such as a thermal runaway, make the end of life management piece much more complex. We need to understand whether there's a risk of reignition, whether there's stranded energy and how to mitigate it, and whether the waste can be handled as a universal waste, as I just mentioned, or in a badly damaged system, it may need to be managed as a fully regulated hazardous waste. So, those are a number of the considerations that you need to be thinking through and you're going to be dealing with at end of life. And again, so really kind of thinking about that now as you're installing new systems and what might happen at the end, what your intentions are when these reach end of life will help considerably when the time comes.
Perfect. I'm going to collapse my two questions in the interest of time as well. And Tom and Bruce, you can choose to respond to it from one or the other, right? So you've both been in the industry for a good number of years. You've seen projects succeed, and then you've seen some of them where we did get significant lessons learned. And one of the things that I hear a lot about, myself being new in the industry, is that we recently see a lot of fire damage systems. So maybe we couple that when we talk about the highlights of our lesson learned. How does those type of challenges change the supposedly smooth decommissioning process?
Yeah, well, I think so. Good question, Jenny. A couple thoughts. One is, from some of the lessons learned that come to my mind, and Bruce has been out executing some of these projects, so I'm sure he's got some others as well. But the things that I know that can sometimes impact a project is things that impact the project schedule, such as permitting. Understanding who the authority having jurisdiction is, obtaining the required permits from those individuals or entities. Sometimes, depending on the scope of the project, it may involve multiple parties. It also may depend on whether it's a privately owned facility or a public institution, such as a school, which we've done decommissioning at those locations as well. So, the length of time that it may take to identify those requirements and obtain those permits can vary widely across jurisdictions. So kind of having an understanding of that up front is super important. As I mentioned, I don't want to dwell on it too much, but EPA does have obligations for those owners and operators of battery systems that have generated waste. And so understanding what those are, that sometimes, one of the steps in that is obtaining an EPA identification number. That can be as easy as a one-day turnaround online, or it can be as complex as requiring you to fill out a form with a wetting signature and mailing it in. We've actually been involved in some projects where there was no viable recycling option in the United States for that particular battery chemistry, so we had to send it offshore back to the original OEM And that requires yet another quite lengthy process to that you must go through with the EPA to get approval to export hazardous waste. And then ultimately just, understanding the scope of the project, particularly on fire damage systems. Kind of as I mentioned, expecting the unexpected. It's because the system has been damaged, inspecting the system in advance to try to understand how significant it was may be difficult or impossible. So, planning around those, what ifs is very important.
Yeah, I might add, Tom, and folks, what an ideal decommissioning might look like. It is a complex and often misunderstood part of the life cycle of an energy storage system. It's not just ripping stuff out and sending it off. It's actually structured and multi-phased process, and it really starts. We've mentioned with permitting, certifications, training of the field team. And then during the pre-decommissioning process and the planning, again, there's some common themes here, which are roles and responsibilities. There's a number of players, stakeholders. We've mentioned some EPCs, contractors, owners, operators, transporters, the recycling company. So clear our, roles and responsibilities that eliminate some of the finger pointing and confusion, obviously. During the execution of a decommissioning project, I'll just start with LOTO, and that stands for lockout, tagout. And what that is these are energized systems, high voltage, dangerous. So we got to make the system safe electrically to work on. That involves locking out and tagging out, de-energizing the system. And then the team generally comes in and removes the batteries first. That involves decabling the power and communication cables off the battery, pulling those out, packaging the batteries according to DOT and EPA regulations. And then disassembling the balance of plant and the ancillary systems like switchgear, transformers, inverters, SCADA cabinets, all of that. And in many cases, decommissioning involves full site reclamation. And that once all the stuff is removed, then what do you have left? You have fencing, you have rock, that's all crushed gravel, you've got concrete pads, you've got conduit. So all of that has to come out as well. And then we make it look like nothing was ever there and like it did before the project even started. That's a complex process. And through it all, I think just documentation and communication are very crucial. The documentation is not just for some potential insurance involvement. We've mentioned fire, thermal systems. There's always insurance folks when there's a thermal event, potential warranty implications or audits. And frankly, batteries, if you're a large waste generator with an EPA ID, there are reporting and record keeping obligations that go on for years. And so I would say that, Jenny, that's sort of what a good plan looks like, a good execution and planning of a decommissioning job looks like. And so, regarding some of the thermal stuff that we've seen on sort of a best practices where people have actually put some forethought before any potential thermal event happens, of reaching out to the local first responders, having some containment protocols for the bad day, if you will. And without that planning, you're kind of forced to do it under some really tough conditions, right? You've got these things are it's not good when a system or a container catches fire. And so without some of that pre-planning, and here's that common theme, planning ahead. We don't fail to plan. We don't plan to fail. We fail to plan, right? The old adage. So just without that, you're improvising under some pretty tough conditions. So I would say that.
Just to add
Thank
one more
you.
thing, Bruce, one thing we talk about we talk about decommissioning as an event. And once things have moved off site and we've restored the facility, that's the end of it. But it really isn't, in the eyes of the EPA, there's a kind of a cradle to grave responsibility for the waste generators. So ultimately, even though you've contracted with people, with entities to take care of this system for you, you need to make sure you're dealing with reputable entities who know the rules, because ultimately, if that waste was not handled properly and it created some contamination, let's call it a Superfund site in a super bad case, ultimately everyone involved in that chain of custody of the battery could be held liable for some financial restitution in trying to remediate whatever situation occurred. So it's very, very important. All of this really continues through well beyond the system actually leaving the site, but going off to be recycled.
Thank you, Tom. I have our last topic, and then we'll move on to the Q&A. And we already have a question number 1 from our audience. So the last question I have for you is, where do you see the industry heading to on end of life?
Yeah.
Has it changed significantly over the years?
I think it has, honestly, and we say over the years, but really, in the last 5 years, you've seen the most, I'd say, dramatic changes. From our first projects that we worked on until to today, it's interesting how the landscape has changed from a just a safety aspect, from a competency aspect. I'd say a few areas where I see, the industry heading. You heard a little bit in the panel session earlier, in some of the breakout session elevator speeches. Circularity is the defining principle in this industry. And so some examples where I think, we will see the industry continue to improve is designing battery packs for repair. So many of the packs that we've worked on, cells are epoxied to the case. There's no possibility of actually replacing a bad cell. In many cases, a battery fails. It may have 52 cells and only 1 cell is bad, but unfortunately, because of the construction, you need to recycle the entire pack. So I think designing and building packs with replaceable cells and modules would certainly enhance, the overall value of a battery system. Designing for transport from day one of the things that we run into a lot on a decommissioning project is, there's certain packaging requirements that you need to meet. And one way to ease that, and I should say that, for the size of these batteries, packaging solutions are not readily available. It takes some time to obtain them, and they're quite costly at times. So designing the battery to have a rigid outer cover allows you to meet some of the DOT requirements for how to package these. So if the battery has a large outer container, it may actually eliminate the need for that separate packaging. And ultimately, I think where we need to get to is to encourage, proper handling of batteries. We need better and cheaper packaging solutions when they are needed. So particularly on the damaged, defective, recalled batteries, they're very expensive. As I mentioned, there's a lead time to get them, and having better solutions for how to safely package, particularly damaged batteries, would be an area that I think we'll continue to see the industry evolve.
Perfect. Thank you. All right. So we'll move to the Q&A. I'll read it off the comment section. And when we have follow-up, just ping me. You don't have to write the whole question. You can ask the question live as well. I'll just kick off the first one. All right. So the first one is from Kimberly Duarte. Thank you, Kim. The question is, what are your thoughts on battery lifecycle management, decommission, and ownership being part of EPA's extended producer responsibility? How much of the framework do you support or encourage? And how would you like to see it in operation?
Yeah, that's a great question. I think so. Extended producer responsibility essentially means that the entity, the producer who put the battery on the market is responsible ultimately for taking those batteries back off the market. I think there's a lot of, look at it. I don't have deep insights into this. This is, certainly, something that's very present in the EU. We have had some experience in the EU. Certainly the benefit is that, I would say one of the gaps we see in the industry is kind of a knowledge gap on behalf of the entity who has procured and installed the battery. They're not battery experts, even though they are responsible for doing the waste classification of the battery at end of life. They often don't have the capability to do that. So putting that responsibility back on the producer makes a lot of sense. As working for a company a former company that produced batteries, we were the experts. We knew exactly how to handle those batteries at end of life, what it was going to cost, where to dispose of them. So shifting the responsibility from the waste generator back to the producer, certainly makes a lot of sense. I think there is some movement in the industry towards that. Some states have implemented some EPR type regulations. I think we're going to continue to see that evolve. It wouldn't surprise me at all if ultimately the US moves much closer to that type of model.
Perfect. We're open for questions. No question?
Ben, I see Ben on here. He actually could have given this discussion because Ben's the expert on particularly on fire damage systems. We worked closely with him and his team in the past. One thing I should mention is, we've got a lot of experience, but one of the things that a company like Renewance relies on is really good expert partners. We have our expertise, but we don't know everything, and so companies, rely on good partnerships. And just a shout out to Ben's team. They're definitely experts in kind of the fire damaged piece of this. So
shout out to Ben and team.
Thank you, Tom. Yeah, glad to always partner with Renewance on many a project. So it's a combined effort in the battery world.
Yeah.
Typically, I hear from prospects how they are quite overwhelmed when they think about decommissioning or even the entire process of planning for it. Any advice that we could, any hack, any tip that we can give our customers, not so much our customers, but our prospects, those who haven't thought about it the way we should be?
Yeah, I might suggest, Jenny, there's a few thoughts. One is, well, just from the costing perspective, right? It can be certainly, if it's not contemplated up front, it can be a cost that's a burden. Typically, near the end of the life, perhaps through degradation, the revenue is down, but the liabilities are increasing. And so those costs if they are contemplated upfront, through getting, partnering again, you're partnering with folks, with a decommissioning plan. You can incorporate those expected end-of-life costs in the project's pro forma, much like you might with O&M costs, operation and maintenance costs, and those just get carried across the life of the project as a budget, as a budget item. And there, it's complex, but it's not crazy, right? We put the things in, and on the end of life, we've got to take it out. We just generally do it sort of in reverse order in many ways, and so the steps are fairly known, and some of the costs, right? We've seen those scale fairly well with, the labor costs, the transportation, recycling. They scale with the size of a project. So if you sort of have one concept of how that works, you can scale that generally for up or down depending on the project size. But some of the unknowns, obviously, this got to be a little bit fluid, because some of the unknowns, if we think about what regulations we know of today from EPA and OSHA and DOT and perhaps others, ask yourself what they might look like in 15 years. That's anyone's guess. So there's got to be some fluidity to the planning process to account for potential changing obligations and requirements as well. If I had a crystal ball, we'd be in great shape, but we don't. But we probably agree that they're going to look somewhat like today, but probably a little different as well. And usually regulations don't get looser, right? They get a little tighter. So I might add that there as a sort of a final thought.
Thank you. We're almost at time. Tom, any final thoughts?
Well, first of all, thank you all for joining. Glad to see good turnout here. Hopefully what we've shared with you is helpful. Like the theme of this conversation, end of life planning really does start at beginning of life. The companies who are going to be successful in navigating these requirements are those who have anticipated the potential issues and have planned for it. So unfortunately, we've seen many who haven't, and we're happy to help them out. But certainly, you can help yourself a lot by starting early, planning ahead, and be ready for end of life when it comes.
Thank you so much. Thank you to Tom and Bruce for the insights, and thank you everyone for joining us. And we'd love to hear from you. We can continue the conversation. Love to hear from you. Please reach out when you can. Thank you.
Yep.
Gord. Someone
Thanks, everyone.
speaking, you're on mute. Thank you.
Thank you.
Thanks, everyone.